Hey, hi everyone, welcome back. This is part 2 of our scatter diagram and correlation study. So if you haven't watched the first part, make sure you do, although I'll walk you through what we did in that first video, but this is part 2, continuing with our study on regression, linear regression, correlationship, and building a scatter diagram basically. But very quickly, what we did on the first one, we imported our libraries that we needed to do a scatter diagram. I brought in a file that is about the temperature in Celsius and the monthly sales of ice cream. So we're studying if the rise in temperature has any impact on ice cream sales. I created two different variables, x and y, and I brought in the columns that I have on the file. Temperature in Celsius is in x, monthly sales is in y, and then we created a very nice looking scatter diagram by using the code that you see here. So that is all explained in part 1 of this video. The question here now is, what do I do with this? What do I do with all of this analysis? Well, when you create a model that is based on a linear regression, and I have here the best fitted line, I can pull an equation out of this, and I can use that equation and I can use this model as a way of inferring statistics. So it's inferential statistics, it's not a guarantee, but I do have an equation out of this model that can help me to predict some sales in this case. What will be my sales based on the temperatures that we may experience, say, in the next week. So the first thing that we're going to do for this part 2 is import another library that I need for this example. So from SciPy, that's the library, from SciPy, import stats. I'm going to run that and make sure that it's okay. It looks like it's okay. So I'm going to use stats from now on, which is what I need to do my first, the first step in polling this regression line. So I'm going to type here a slope, intercept, R value, P value, and the standard error, and that is going to equals stats dot lean regress of x and y. And just to make sure that this has no problem, I'm just going to rerun the cells here to make sure that that change is actually picked up. And it looks like it worked. So what this does, in a very efficient way, it gives us our coefficient. So if I want to look at the slope coefficient, for example, there it is, 21.39. And I also need the intercept. I need the intercept for my equation. Oops, sorry, I missed the t here. Good thing, you can see I got an error. Everything is coding, has to be perfectly matched. And what I'm going to do here is also to get the R value, which is your correlation coefficient. So this is just how close the two variables are related to each other and also in which direction they're moving. In the first video, I explained that this is a positive, moderate correlation, and I can confirm that by looking at the 0.77 coefficient. So this coefficient can only go from -1 to +1. Because it is positive, it's moving in a positive correlationship direction, and because it's almost 7.8, it's between like moderate to strong correlationship. Okay, so the next thing that I want to do here is, now I have my intercept, and now I have my slope. And if you recall a linear regression equation, it's basically like this: y equals a plus bx. Y is my variable of interest, which is sales in this case. A is my intercept, which I have, and then B is my slope, which I also have. X, in this case, it's our temperatures, which is on the x-axis. So that's my independent variable. So that's basically the model of the equation of the linear regression model. So what I can do here now is I can say, okay, now that I kind of know that this is going on, there is this linear regression going on, how can I predict my sales based on temperature? Well, we can create a new variable here. I'm going to create a new variable called tempEst, temperature estimate. And I'm just going to create a pandas series, pd.series. And in that series, as an example, I'm just going to say, well, I want to work with kind of a table. I'm going to say between 0 and 30 degrees, increments of 5. So 0, 5, 10, 15, 20. I just want to have an idea of what types of sales I'm going to get if those temperatures were to be the temperatures of the day in Celsius. So I created that series, and just to check, I always like to check what I'm doing on the variables here. So there it is. It's just a series with certain numbers, and in this case integers, right? So that's my variable tempEst. Okay, so because I know that the linear regression equation is written this way, and because I have these coefficients, I'm going to try and create a little bit of a formula here, a little bit of a computation here to actually create me a table that gives me the predicted sales based on these temperatures. You can create random numbers if you want using NumPy. You can type whatever. You can do increments of 1 degrees if you like. Again, we're just setting this up, right? So we can predict the sales. So the next things that I want to do is I'm going to create another variable called sales estimate, and it is an estimate. This is not a perfect model, but I can have some sort of estimation based on the temperatures according to my linear regression, according to the data set that I worked on. So my sales estimate variable is going to equal the PD series I'm going to add the intercept, which is a value that I have here, plus the slope. Remember the equation, intercept plus slope times the variable of interest here, which, sorry, not the variable of interest. The variable of interest is my sales, but the one that I'm trying to use to estimate from, which is the series here, right? It's my temp estimate. So times temp estimate. So basically what I'm doing here, I'm saying pandas, create a series that uses this formula. Intercept plus the slope, which again are values that I have from my linear regression equation, times the temperature estimate. Just create another series like that. So sales estimate, if I want to see what's in there, beautiful. So now I have my sales estimation based on the linear regression equation that I created out of the data that I had available. Very cool. So obviously, as you change the numbers here for the temperature estimates, your results, your output would change here. Now, let's make this look a little better. You know, it would be kind of odd to look at numbers like this. Imagine if you have increments of 1 and you have like 30 lines in here. So what I'm going to do next is I'm going to put this together. I'm going to combine these two series in a nice, neat table. So for that, I'm going to create another variable. I'm going to call it the F2, and again, you can call it whatever you'd like. And in here, I'm going to create a data frame. So I'm calling pandas, create a data frame. And in this data frame, I'm using a dictionary here. I'm going to say, well, I typed in temperature estimate. Again, you can call it whatever you'd like, but I think this makes sense. That's going to equal my tempEst series. and then for the sales estimate, my sales est series. So I'm basically combining the two series into a table. Fingers crossed, let's see if it works. Awesome. So that's my table based on my temperature estimates, giving my sales estimates. Again, you could say, I don't like the increments, change the increments. You can randomize these numbers. One way or the other, you can create a series, apply the linear equation, and somehow have a good predictability on your sales estimate. Now, before we wrap this up, the other thing that I wanted to caution you with is what we call the R squared. So if I look at the R valued and I simply square that, R valued is squared, I get 0.60. The R squared is an indication of how much of variation in Y, which is in this case sales of ice cream or sales in dollars, is explained by X, which is the temperature. So this equation, this model, it's only explained 60%. In other words, this model is showing us that the sales per month, which is our Y, our dependent variable or response variable, all of the variation that we encounter in that, it's explained only 60%. I shouldn't say only, 60% is a pretty good number, but 60% from the temperature. In other words, there's still about 40% of variation in the model that is not explained by temperature. And this will be other things such as, finding a parking spot at the ice cream parlor, or not being able to leave home because of a storm, or whatever the case may be. It's important to point out that this is absolutely not a perfect model. And the other thing is too that we cannot say for a fact that this is a causal relationship, a cause and effect relationship, but it is a model, it is predictive somehow, and it gives the business owner here, the decision maker, of course, a good estimation of sales based on temperature. So that is it. I just wanted to do this part 2 and show you how you can actually learn from regression and learn from studying two relationships and applying this to some sort of predictive model. I hope you enjoyed this lesson, and I hope to see you next time.